Hi everybody, today we're going to talk about finding geometric mean. By definition, the geometric mean between two numbers is the positive square root of the product of the numbers. Remember, product is the answer when you are multiplying, so it implies multiplication. So here's how you find the geometric mean of two numbers, which here we'll just call A and B. You set up a ratio or an equation with ratio. So you say A over X, X is your geometric mean, equals X over B. So one time X is on the bottom, one time X is on the top. Then when you cross multiply here, you get X times X, which is X squared, and then A times B, which is AB. And then you clear the square by taking the square root of both sides. So here's what you end up with: the positive square root of the product of your numbers. So by following this process, you can end up with the geometric mean. So let's give this a try. This is find the geometric mean of 4 and 9. So we're going to set up our ratios. So we say 4 over X equals X over 9. So one time X is in the denominator, one time X is in the numerator. So then we get X squared equals 36. And then we take the positive square root of both sides. Usually we would put the plus or minus, but here we just want the positive. And in this case, this is a really nice number, because the square root of 36 is 6. So that's our geometric mean. All right, let's try one more together. Find the geometric mean of 6 and 15. So we'll say 6 over X equals X over 15. So here we're going to cross multiply. So we have X squared equals 90. So we'll get X equals the square root of 90. This is not a perfect square, but we can simplify this. Remember, the way that you simplify a radical is by making a factor tree. So you're going to factor it out until we have all prime factors, meaning you can't divide any further. So what we have now, I'm going to list them all out. We have 2 times 3 times 3 times 5. And then you circle pairs of factors, and when you do that, one of them will escape. So although we circled a pair, only one of the 3's escapes. Now you can see that what we have left inside our radical is 2 times 5. So it'll be 3 times the square root of 10. So same process to find that geometric mean. This one just had a few extra steps because we did need to simplify our radical. All right, so go ahead and pause the video and give this problem a try. Okay, let's go ahead and check our work. So you could check the setup, cross multiply. So here we get X squared equals 225, so X is the square root of 225. Now 225 is actually a perfect square. It's a perfect square of 15, but that's not what I would expect you to know. So you can factor it out, and you find that you have a pair of 3's, a pair of 5's, so there's nothing left inside your radical, so it's just 3 times 5. Here we get X squared equals 80, so X equals the square root of 80. If you simplify it, you get 2 times 2 times 2 times 2 times 5. This pair turns into this pair turns into this. We have a 5. And then you multiply the 2's on the outside, and you get 4 times the square root of 5. All right, so for the next few, we are going to need to do a quick vocab review. So remember, an altitude is when you go from the vertex of a triangle down and it creates a 90-degree angle. So that's an altitude. A right triangle is any triangle that has a 90-degree angle, denoted by the little box. And this might be new. So this word hypotenuse, it always is going to represent the side that's across from your 90 degrees. So this is our hypotenuse. And the word leg is always going to be used to describe the two sides that are touching your 90-degree angle. So this is a leg, and this is a leg. So we're going to need to know this for the next two theorems we're going to talk about. So our first theorem says the measure of the altitude from the 90-degree angle of a right triangle is the geometric mean of the two segments of the hypotenuse. So let's talk this through. So the measure of the altitude. Our altitude is YW. This is our geometric mean. And it says of the two segments of the hypotenuse. Well, this is our hypotenuse right here. So those two segments are XW and YZ. So those are the two parts we're going to use. So we're going to say XW over YW, which is our geometric mean, equals YW over WZ. So you can see that our geometric mean occurs in the denominator and the numerator. So we can set up this type of ratio to solve for our altitude. All right, so here in this example, we're given a right triangle and we have an altitude drawn from the 90-degree angle. So let's label what we have. It says RS is 3, QS is 14, and they would like us to find PS, our altitude. Well, we know that we can set up this ratio because the altitude, which is X, is the geometric mean of the two segments of your hypotenuse. So now we're just going to cross multiply. So X will equal the square root of 42, which you should check to see if we can simplify. So we know that 42 is 6 times 7. And you might notice that there are no repeating prime factors. So square root of 42 is simplified, and that is our answer. All right, go ahead and pause the video and give this one a try. Okay, so you can see that this is 2, this is 5, and our altitude is x, and the altitude is the geometric mean. So 2 over x equals x over 5. So x will equal the square root of 10, which cannot be simplified. All right, the last theorem we're going to talk about says that if an altitude is drawn from the 90-degree angle of a right triangle to the hypotenuse, just like in the last example, then the measure of the leg, either leg of the triangle, is the geometric mean of the hypotenuse and the segment of the hypotenuse that is adjacent, meaning next to that leg. So this one could be a little bit trickier, but what's important to note is that the leg is the geometric mean. So one way we can set this up is we can do our entire hypotenuse, which is xz, and then over our geometric mean, which is xy, which means xy goes on the top here, and it says the hypotenuse, which we already used, and the segment of that hypotenuse that is next to the leg. So I'm going to use this segment, not this segment. So I'm going to say xw. But we can also create a ratio using our other leg. So let's say we use this leg as our geometric mean. So we can say our entire hypotenuse, which is xz, over our geometric mean, which is yz, equals yz, over, now we're going to use this segment of our hypotenuse because it's closest to our leg. So wz. All right, so let's give this first problem a try. They would like us to find x and y. Okay, so the first thing we'll do, let's start by solving for x, which is going to be our geometric mean for one of our setups. So we're going to do first our entire hypotenuse, which is 6. So we can say 6 over x equals x over the segment that is closest to that leg. So we'll say 4. Then cross multiply, take the square root of both sides, and if we simplify that, so we get 2, 3, 2, and 2, we end up with 2 times the square root of 6. Now we can do the same thing, except this time we're going to be solving for y. So I'm going to use this as our geometric mean. So we'll do the entire hypotenuse, 6 over our geometric mean, so it goes top and bottom. And then we're going to use this segment of our hypotenuse because it's closest to the leg that we're using, so 2. So we have y squared equals 12. Y equals the square root of 12. And if we simplify that, we get 2 times 6, 2 times 3. So here's our pair. So y equals 2 root 3. All right, go ahead and pause the video and give this one a try. Okay, let's go ahead and check your work. So you can see that we did total hypotenuse over x equals x over 2, which is the segment closest to x. And then we do total hypotenuse, 16 over y equals y over 14, which is closest to y. So you should get x equals 4 root 2 and y equals 4 root 14. All right, that is all for today. Thank you for watching.